Hello students, we are going to understand some of the prerequisites of an experiment called RC circuit. When we talk about R and C, we know that R represents the resistor which is represented by R and C represents the capacitor. Now let us try to understand what is resistor and what are the prerequisites related to the resistor that has to be known to a particular person before going to perform this particular RC circuit experiment. And we know that resistor is an electrical element which opposes the flow of charge, or in other words, which opposes the flow of current. And in general, the resistor symbol is given by this one. This is the symbol for resistor symbol. Now, when we see the real resistor, how it will be? It will be like this. There will be two leads. This is one and this is second one, lead one and lead two. And if you see, this is actually the resistor. If you particularly observe this resistor, there are some color bands are available on this resistor. So we need to understand what is the meaning of these color bands, why they have given on this particular resistor. And if you see, in general, the resistance of a resistor is measured in ohms. And if you see this particular resistor, there is no value of the resistance is given on this particular resistor. The number is not written on this resistor. Now, what we need to do is to understand the resistance value of a given resistor, we need to understand something called color coding or the color bands which are available on this particular resistor. So we need to extract the value of resistance from the available color bands on this given resistor. To understand this color coding, we need to first understand what are the colors that might be available on the resistor. The series of colors that may be available on the given resistors are black, brown, red, orange, yellow, green, blue, violet, grey, white, gold, silver. Now what are all these colors? In general, if you take a resistor like this, for example, and there are two leads are available, and in general, one side there will be three different colors. One side there will be three colors, and other side there will be one color. This is the general resistor colors that are available on the resistor. But sometimes what happens is there may be also the fourth color on the left side will be available. So these three colors or four colors that are available on the left side represents the value of the resistance of a given resistor. On the other hand, the color which is available on the right side, this represents the tolerance of the resistance value, the tolerance in the resistance value. For example, this tolerance is given by two colors, that is, first one is gold, or second one is silver. That means on the right hand side we can have either gold or silver. If gold is present, we can say there is plus or minus 5% in the resistance value. This is called tolerance. Plus or minus tolerance of 5% is available in this particular resistance value, which is going to be calculated from this first four or three colors. Similarly, if there is a silver color on the right hand side, we can get plus or minus 10 percentage of tolerance in the observed or the calculated resistance value. Now, let us try to understand what is these colors. For example, if I take these colors, first color is A, second color is B, third color is C, and fourth color is D. What is this ABCD? These are the actually variables, okay now, for which we have assigned some numbers. For example, if you take A, B, C and D, these are the numbers, actually the numbers which are assigned to the respective colors. For example, if you see this table, I have assigned one number black, I have assigned 0. For brown, I have assigned 1. And for red, I have assigned 2. Like this, for every color, I have assigned some different numbers. So, based on these particular colors that are available, we can actually calculate the value of resistance. In general, the resistance value is given by ABC into 10 power D ohms. This is the formula to calculate the resistance value of a given resistor from the color coding. What are these A, B, C and D? These are the numbers assigned to the particular colors. Okay, now for example, if there are only three colors are there, this is the formula for four colors on the left side available. Now there are, for example, only three colors are available. Then the formula becomes AB into 10 power C ohms. As simple as it is. Now, if you try to take one example, we can easily understand how can we determine or calculate the value of resistance of a given resistor from the color coding. And please note that this A, B, C and D represents the numbers assigned to the particular colors, the respective colors. For example, if I take one resistor, this is a resistor which has some colors on this. These are the three colors on the left side and gold is on the right side. Always gold or silver we need to keep on the right side. Now, for our calculation, we are not considering the tolerance. For our experiment purpose, we are not considering the tolerance. So, forget about this gold or silver, whatever it is there. We are not considering that. Then we need to consider these first three colors in order to determine the resistance value. How do we determine? First, we need to understand what are the colors are available. The colors are, first one is brown, second one is black, and third one is red. And we know, for example, this is A, B and C. So what is the number that is assigned to the brown color from the table? If you see, that is 1. So for example, this is A is equal to 1. And similarly, if you take black color, what is the color that is assigned to this particular black color? That is 0. And for example, second, so I am taking B is equal to 0. And similarly, third, red color we have given, what is that? 2. Number is assigned, that is, for example, C is equal to 2. Now, if there are only three colors on the left side, what is the formula for resistance? R is equal to AB into 10 power C ohms. Now, we need to just substitute the values of A comma B comma C, which are the numbers assigned to the respective colors in this particular formula. Then what you will get? A is equal to 1, B is equal to 0 and C is equal to 2 ohms. So, yeah, this is how we need to actually calculate the value of resistance of a given resistor by using color coding. So it's very simple. Hello students, the next concept to be understood in RC circuit is the capacitor. So we have studied in electrostatics about the capacitor. What do you mean by capacitor? Capacitor, an electrical element. It is an electrical element which stores charge in the form of electrostatic energy. It is a device, electrical device, which stores electrical charge in the form of electrostatic energy. And its symbol is given by this one. This is the symbol for capacitor in general. And the capacitance is measured in its capacitance and whose units are farad. Whose units are farad, represented by F. Or most of the times we use microfarad to represent the capacitance of a given capacitor. And if you see the construction of capacitor, it will be like this. There will be two, in general, there will be two metallic plates. In general, they will be parallel, and these metallic plates, parallel metallic plates, or the conductors, are filled with some material which is known as a dielectric material. This is nothing but a dielectric material, and this entire setup is known as a capacitor. Capacitor means which has two parallel plates made up of with metal or conductors, and between these two parallel plates it is enclosed with, or it is embedded with the dielectric material. Now, based on this dielectric material, we have different kinds of capacitors, starting from ceramic capacitors, means the dielectric material which is used between these two metallic parallel plates is ceramic material. And second one is maybe paper capacitor, that means the dielectric is paper, and it may be a plastic, so this is also known as plastic capacitor. And the fourth one is electrolyte. For example, if the dielectric medium used between these two parallel metallic plates is an electrolyte, then that particular capacitor is known as electrolytic capacitor. In general, we will be using in our RC circuit experiment this electrolytic capacitors, which is shown here. This is the electrolytic capacitor, and if you try to see this capacitor, so there are two leads, 1 and 2, and one is, if you try to observe, one lead is longer than other one. That means the longer lead actually represented positive terminal, and the shorter one represents the negative terminal. On the other hand, we can see some number on this capacitor in microfarad. This represents the capacitance value of this particular capacitor. So here in this example, it is written as 2200 microfarad. So this is the value of capacitance of this particular capacitor. So there is no color coding as we use in our resistor. By directly looking at this number represents the capacitance. It is written on this capacitor. So no need to worry about the capacitance value of a given capacitor. So this capacitors we are going to use in our RC circuit as a basic element. Hello students, we are going to understand one more concept in RC circuit experiment, that is about breadboard. Let's try to understand what is a breadboard and what is the use of this breadboard. So breadboard is a platform where the electrical or electronic components will be placed in order to produce a circuit. For example, if you take a simple circuit, there is a resistor, and for example, there is a capacitor, right? And there is a battery, for example, something like this. And for example, there is an ammeter here, something like this. There is a circuit like this, something. Now, if you want to implement this circuit, we need a platform. That platform which we are going to use is known as a breadboard. So, let us try to see how this breadboard and how do we use this breadboard in order to connect the given electrical elements according to the circuit. And this is a picture of a typical breadboard. And this breadboard, if you see, there are some holes are drilled on this breadboard. There are holes are drilled on this breadboard. And if you try to see in this particular breadboard, you can see this top and the bottom portions of this particular breadboard are looking same or similar to each other, right? That means the property of this top portion and bottom portion is same. On the other hand, if we try to see these middle two portions are looking similar, and hence the property of these two will also be same. And this middle portion and top and bottom portions are not looking same, not looking similar. That means the property is going to be differ from top to middle or middle to bottom. Only one thing we need to remember is the middle portions are having same property and top bottom portions are having same property which is different from the middle portions. So let us try to see what is this property. And if you try to see this top and bottom, there are horizontal holes. There are horizontal holes. Look at this. These are the holes. And in top and bottom portions of the breadboard, all these horizontal holes are connected to each other till its middle point. And there is a break. Then again, from middle to the right side, all the horizontal holes are connected to each other. They are electrically connected. In other words, they are shorted each other. Similarly, we try to see the second row, the second horizontal holes also are connected to each other. So this is the property. And look at this. Vertically, the vertical holes are not connected to each other. That means these two horizontal rows of holes are different. This is connected individually and this is connected individually. There is no interconnection between the horizontal lines. The similar property is also applicable to the bottom portion of the breadboard. Look like this. It looks like this. They are connected to each other horizontally. They are connected to each other horizontally. Right? Now, that means what? For example, if I take a resistor, this is a resistor for example, and I take a capacitor like this. Okay, I want to connect these two terminals together. Then what I need to do is, I need to fix this terminal here, the second terminal, and the same horizontal line somewhere. Then what happens is, there is a connection established between these two terminals. Similarly, here also, if you want to connect these two terminals together, you can also connect here and somewhere here. Then there will be a connection established between these two. And look at this, there is a break actually. There is no connection here. That means You can use from here to here as single line, single connection. But there is a break. Again from here to here it is shorted. Similar case in case of bottom portion. Now, if you come to the middle portion, I told you the middle portions are having different property than top and bottom. So what is that property? It is exactly opposite to the top and bottom. What we understand from top and bottom? In top and bottom, horizontal holes are connected to each other, whereas in case of middle portions, the vertical holes are connected to each other. Vertical holes are connected to each other. There is no horizontal connection between these holes. That means these holes are shorted vertically and horizontally there is no connection. For example, similarly, if I want to connect a resistor this end and capacitor this end, I wanted to connect both of these together. Then what I need to do is I need to connect this resistor somewhere here and this capacitor. You can connect in any of these vertical holes. For example, here you can connect something like this. Then what happens is these two terminals are connected in a single vertical line and hence they are shorted, they are connected to each other. And there is no horizontal connection. That means they are separated horizontally. Look at this, there is no connection between this one and this one. They are separated each other. Similarly, this one also, the second portion of the middle, if you try to see, they are shorted vertically and there is no horizontal connection, right? And if you try to see these two parts, let's say this part 1 and this part 2 of the middle portion, there is a break again. This is the break actually, this is a break. That means these vertical lines are not continuous from the part 1 to part 2. There is a break that we need to actually understand. So only one conclusion from this breadboard is the top and bottom portions of the breadboard are shorted, or in other words connected horizontally. There is no vertical connection. And in case of middle portion, the holes are connected vertically, there is no horizontal connection.